everyone. Today we will discuss about Taylor's theorem. Okay. So let the statement f is a mapping from closed interval a comma b to R says that first condition is f is its successive derivatives. Those are f dash, f double dash, f bar n for all n belongs to n are continuous on closed interval a comma b. This is the first condition. These all derivations satisfies the continuous condition on closed interval a comma b. And second condition has given f bar n plus 1 exists on open interval a comma b. So if suppose x naught belongs to closed interval a comma b, then for any x is nothing but element in a comma b, then there exists a point c belongs to open interval a comma x comma x naught, such that the condition of Taylor series is this condition. So f of x equal to x naught plus x minus x naught by 1 factorial into f dash of x naught plus x minus x naught square by 2 factorial f double dash of x naught plus so on. Here x minus x naught power n by n factorial f power n of x naught plus x minus x naught whole power n plus 1 by n plus 1 factorial into f power n plus 1 of c. This is the series of Taylor's. Okay, we'll prove this condition. So here what has given, the function is nothing but mapping from f closed interval a comma b to R. Right now, so first condition what has given, f is continuous. That means successive derivations we need to take here. F dash, f double dash, all the derivations should be satisfy the continuous condition on closed interval a comma b. Okay, and here for given x naught and x, two elements we are choosing. These two are elements in closed interval a comma b only. Okay, and let the interval is nothing but I am defining I is equal to either x naught comma x, or we can take x comma x naught also. According as x naught is less than x, we can take r x naught is greater than x also. Okay, and we are defining the function f from I tends to r. I is nothing but closed interval. R is the set of real numbers. Okay, and the function is nothing but the series we are defining in this function. F of t is equal f of x minus f of t minus x minus t by 1 factorial into f dash of t, so on x minus t whole power n by n factorial f power n of t minus a into x minus t by x minus x naught whole power n plus 1. For all, here t is nothing but element in this interval I. Okay, and make this equation 1 where here a is nothing but element in the set of real numbers. Okay, and f of x naught is equal to f of x. This is the continuous we are saying. So that's what we are taking. These two functions are equal. Okay, suppose here f of x naught is equal to f of x, you should take. In this I am choosing because here put t is equal to x naught. Okay, and f of x, it should becomes f of x minus f of x naught minus x minus t is there, x minus x naught by 1 factorial f dash of, here t is there na, x naught you should write, so on. Here x minus x naught whole power n by n factorial f power n of, instead of t, x naught you should take, and in the minus a into x minus t means x minus x naught by x minus x naught whole power n plus 1. X minus x naught means here it should get cancelled. Okay, so that means x minus x naught by x minus x naught whole power n plus 1. Here x minus x naught should get cancelled, no? So minus a will be there. That should be is equal to 0. Okay, and from the conditions 1 and 2, from the statements we should see here, from the condition 1 and 2, in this case satisfies continuous as well as derivable. Those are from these two conditions, successive derivations f double dash, f triple dash, so on, f power n. These all are continuous on closed interval a comma b. And all the functions, successive derivations, f dash, f double dash, so on, f power n These all are continuous on the interval I also. I is nothing but what? It is the subset of subinterval of closed interval a comma b, and f bar n plus 1, this should be exist on this interval. So f bar n plus 1 is also nothing but exist on the interval capital I only. So further we can say every polynomial in T, namely we can take x minus 3, x minus 3 square, x minus 3 whole cube, so on x minus 2 whole power n, and x minus 3 by x minus x naught whole power n plus 1. These all are continuous as well as differentiables on the interval I. Yes. So now already we discussed now f of t is nothing but continuous and derivable on closed interval I. So here f of x naught and f of x both are equal to each other, right now. So by Rolle's theorem we'll take here. By Rolle's theorem, what is the condition? It should be exist at least one element in between a and b. Those are, we are taking must c belongs to open interval a comma x naught, so that f dash of c is equal to 0. This is the condition of Rolle's, right now. And where t is nothing but element in I. So from first equation what is there? F of t is equal to f of x minus f of t minus so on is there, no? You should derivative with respect to t on both sides. So f dash of t is equal minus f dash of t. There f of x is nothing but constant, so it should become 0. So minus f dash of t minus x minus t by 1 factorial into f dash of t is there. That is UV method you should apply ma. So minus 1 into f dash of t plus x minus t into f double dash of t minus so on. Here minus of minus n into x minus t whole power n minus 1 by n factorial f power n of t plus x minus t whole power n by n factorial into f power n plus 1 of t. It should becomes after derivating first equation. And minus a into minus 1 n into n plus 1 x minus t whole power n by x minus x naught whole power n plus 1. Okay ma'am? Here f dash of t it should be equal to minus f dash of t. So you should simplify this. Minus f dash of t minus into minus plus f dash of t. Here f dash of t plus f dash of t minus f dash of t should get cancelled. And minus into minus plus minus x minus t whole power n by n factorial f power n plus 1 of t, and the remaining terms are also should get cancelled. Remaining terms, these two are will be there. Okay. So minus of x minus t whole power n by n factorial f power n plus 1 of t plus a into minus 1, minus into minus plus will come here, n plus 1 into x minus t whole power n by x minus t whole power n plus 1. So here what are the terms should get cancelled ma? X minus t whole power into f double dash of t and plus term also will come. So all the terms should get cancelled, remaining terms these two are there. Okay, and we know that by Rolle's theorem f dash of t should be is equal to 0, right now. So from this equation we should get f dash of c. Put here t is equal to c. Okay, and f dash of c is equal to minus, instead of t you should substitute here c minus x minus c whole power n and by n factorial f power n plus 1 of c plus a into n plus 1 into x minus c whole power n by x minus x naught whole power n plus 1. And here we are taking a into this is we are writing in first term. So a into this term here and minus term I am taking in the second term, and in this case we are taking the common term x minus c whole power n. Okay, I am taking the common x minus c whole power n, and remaining terms I am writing here equal to 0 is there. It should becomes cancelled. Okay, and remaining term you should write here a into n plus 1 by x minus x naught whole power n plus 1 minus 1 by n factorial f power n plus 1 by 1 of c is equal to 0 is there. This minus term you should take on the right hand side. It should become a into n plus 1 by x minus x naught whole power n plus 1. It should be is equal to f power n plus 1 of c by n factorial. Okay, and from this we'll find a value. From this we are finding a value. A is equal to f power n plus 1 of c by n factorial into it should becomes x minus this total divided by n plus 1 by x minus x naught whole power n plus 1 will be there. but I am writing 1 here into x minus x naught whole power n plus 1 by n plus 1, where here always x is not equal to c only. So a is equal to, you should simplify x minus x naught whole power n plus 1 by n factorial into n plus 1 is there. N plus 1 into n factorial, simply we can write n plus 1 factorial right now into f power n plus 1 of c. You should write, make this equation 4. We are substituting this equation 4 in equation 2. Okay, then we should get f of x minus f of x naught minus x minus x naught by 1 factorial f dash of x naught, so on, x minus x naught whole power n by n factorial f power n of x naught minus x naught whole power n plus 1 by n plus 1 in factorial f power n plus 1 of c is equal to 0. So there, instead of a, we are substituting this term. Okay, and from this is equal to 0 is there. These minus terms, all the terms we should take on the right hand side. We should get the final result. F of x is equal to f of x naught plus x minus x naught by 1 factorial f dash of x naught plus so on, x minus x naught whole power n by n factorial f power n of x naught plus x minus x naught whole power n plus 1 by n plus 1 factorial f power n plus 1 of c. Okay, this is the Taylor's expansion, very very important theorem. Okay, yeah, we discussed already about Taylor's theorem, no? So we have Taylor series also. So by using Taylor series, we'll find this problem. Okay, and write Taylor's theorem with Lagrange's form of remainder. For f of x has given here log of 1 plus x, where a is nothing but given 2 and n is equal to 4. So number of terms 4 are there. So 4 derivations we have to find. Now we know that f of x is nothing but from the statement what has given log of 1 plus x has given, no. So it has nth derivative. Okay, where x lies between 2 minus h, 2 plus h, where h is nothing but positive, and f power n of x is nothing, n of x equal to minus 1 whole power n minus 1 by 1 plus x whole power n minus 1 factorial. You should take this condition from the Taylor series, nth term I am taking, okay, directly. If suppose put n equal to 1, 2, 3, up to how many are there? 4 are there. So 4 terms you should substitute. N equal to 1 I am substituting f dash of, here f power n of x means f power 1 of x is equal minus 1 whole power n minus 1. N equal to 1, 1 minus 1 is 0. Minus 1 whole power 0 is 1 by 1 plus x whole power 1 is 1 plus x only will come, 1 minus 1 0 factorial. 0 factorial is also 1. Okay, and 1 factorial is also 1. Should remember 0 factorial and 1 factorial is also 1. And if n equal to 2, you should substitute in this expansion. F power double dash of x is, it should be is equal to minus 1 whole power 2 minus 1 is 1, minus 1 whole power 1 is minus 1 only, by 1 plus x whole square into 2 minus 1 is 1 factorial. 1 factorial, what I said, it should be 1. So its derivation is nothing but we should get minus 1 by 1 plus x whole square. Okay, and if n equal to 3, I am substituting in this expansion, f power triple dash of x, it should be is equal 3 minus 1. 3 minus 1 is 2. Minus 1 whole square. Minus 1 whole square is nothing but positive. Okay, 1 will come. 1 by 1 plus x whole cube into 3 minus 1. 3 minus 1 is 2. 2 factorial is 2 only. Okay, and 2 by 1 plus x whole cube we should get. And lastly, n equal to 4, you should substitute in this expansion. F power 4 of x, it should be is equal to minus 1 whole power 4 minus 1. 4 minus 1 is, we should get 3. 3 is odd. Minus 1 whole cube is minus 1, you should get by 1 plus x whole power 3 only. n minus 1 factorial. 4 minus 1 factorial. That should be is equal to 1. 4. Sorry, it is 4. 4 minus 1 factorial, it should be is equal to minus 6 by 1 plus x whole power 4. Because 4 minus 1 factorial means 3 factorial. We should get 3 factorial. We can write 3 into 2 into 1. 3 2s are 6, 6 1s are 6. So 6 by 1 plus x whole power 4. Minus will come. So that's what we are getting, minus 6 by 1 plus x whole power 4. Okay. Now here we find all the derivatives. S no, f dash, f double dash, f triple dash, f power 4 dash. So these all are continuous on this closed interval 2 minus h comma 2 plus h, as well as all the derivatives, successive derivatives are differentiable on open interval 2 minus h comma 2 plus h by using Taylor's expansion or Taylor's theorem. We should already we know that condition na, f of x is equal to f of x naught, means f of 2 here a place lo 2 substitute cheyandi. F of 2 plus x minus 2 into f dash of 2 plus x minus 2 whole square by 2 factorial f double dash of 2 plus x minus 2 whole cube by 3 factorial f triple dash of 2 plus x minus 2 whole power 4 by 4 factorial f power 4 of 2. Okay, and f of x is nothing but from the statement what is there, log of 1 plus x, right? No, right, instead of f of x, log of 1 plus x, it should be is equal to f of 2. F of 2 means log of 1 plus x. 1 plus, instead of x we are substituting 2. 1 plus 2 is nothing but 3. So log 3 plus x minus 2 into f dash of 2. F dash of 2 means here f dash of 2 is nothing but what is there, 1 by x. So instead of x we are substituting 2. 1 plus 2, that is 1 plus 1 by 3. X minus 2 into 1 by 3 plus x minus 2 whole square by 2 factorial into f double dash of 2. Here f double dash of 2 what is there ma? Minus 1 by 1 plus x whole square minus 1 by 1 plus 2. 3 square, that should be is equal to minus 1 by 3 square means 9. So that only we are writing minus 1 by 9 plus x minus 2 whole cube by 3 factorial into f triple dash of 2. F triple dash of 2 is nothing but we have here 2 by 1 plus x whole cube. So 1 plus 2 is 3. 3 cube means 27. 2 by 27 plus x minus 2 whole power 4 by 4 factorial into f power 4 derivation, fourth derivation. Fourth derivation minus 6 by 1 plus x whole power 4 is there. Okay, x plus lo 2 substitute chestama, 1 plus 2 is 3. 3 power 4. 3 power 4 means 81. Okay, this expansion we should get. So minus 6 by 81 means after simplifying this expansion, log 3 plus x minus 2 by 3 minus, because plus into minus, minus x minus 2 whole square by 2 factorial is nothing but 2 into 1 only. Okay, and into 9 is there, 9 2s are 18 and plus x minus 2 whole cube by 3 factorial. 3 factorial what I said, 3 into 2 into 1, 3 2s are 6 and 6 means here 2 is there na, x minus 2 whole cube into 2 by 3 factorial means we are getting 6 into 27. 2 1s are 2, 3s are 6. So 27 into 3, 81 we should get. Okay, x minus 2 whole cube by 81 will come minus last term what is there, x minus 2 whole power 4 by 4 factorial. 4 factorial means 4 into 3 into 2 into 1 into here in numerator x minus 2 whole power 4 will be there, minus 6 by 81 is there ma. Here 3 2s are 6, 2 should get cancelled, minus into plus minus will come and 81 into 4, 81 into 4 324. Okay, this is the expansion of log of 1 plus x. So this is the expansion.